There, my year eights, welcome to science. Now, for the majority of you, congratulations because you have just completed and handed in your student research project, your poster, and that was a very big project. So, congratulations, well done. We're going to just take a moment. We're not going to move on to a new topic yet. We'll do that either later, next lesson or next week. But for now, we're just going to take a moment, just this lesson, just a short lesson today, in order to just have a thought experiment. Think a little bit broader about science. So, we're going to kind of check about what you've done before. So, firstly, you already know this scientific process. This is the scientific method, and you guys have just finished a whole project running through individually this scientific process. So you posed a question, and some of you took a while to figure out what question you might want to ask. You posed a hypothesis and an aim. Then you designed an experiment. You collected some data. You added it and you measured some things. You made up some tables and graphs. You found out hopefully an answer and drew a conclusion. And then via a digital poster this year, you communicated your findings. And then as scientists, this is the chain of events that we do on a daily basis. Now, this process actually was firstly kind of thought about around Sir Francis Bacon back in the early 1600s, like mid 1550s, etc. So Sir Francis Bacon, before him, the process to figure out new knowledge about the world around us was very different. You observed something, you thought that that's the way it worked, and if you were prominent in that society and had a little bit of knowledge about you, then people just took your answer for how things worked as gospel, as something that you go, okay, sure, if you think that's the way it works and you have a good argument for it, great, not a problem. And they took that on board. Now, we know that to learn about the world around us, that's a bit of a difficult thing because anyone can sprout any idea. They can come up with a really fancy, wonderful theory about how things work, and they could be the most influential speaker ever, but that's not to say that they're correct. Sometimes they aren't. So people taking that on board is not a good thing without evidence backing them up. So Sir Francis Bacon was one of the first to figure out a process and a way, the scientific method, in order to get evidence and to have a process by which people could agree on and find a way to move forward about new knowledge, and then reproduce that and repeat the experiment, and other people could do the same thing in order for us to not just take their word for it, but also do the experiment ourselves, and we should get the same result. So that was Sir Francis Bacon. I know in history, and which is another reason why we're doing it today, in history I know you're going to look at the Renaissance, and in the Renaissance period, back in history, there was the scientific revolution. So Sir Francis Bacon was one of the people in that the start of that scientific revolution. Now, Mrs. Taylor is going to go through this in a little bit more detail, but this is like a segue for us to get to this thought experiment and this kind of thought process first. So we're going to look at today, looking at the past and a little bit of the Renaissance, a little bit of scientific revolution back in the 1500s and 1600s, to then kind of move forward and think about what is occurring in the future. Okay, so the first thing is not too far back in history. This is Thomas Kuhn, who is an American physicist back in the 1960s, which is not too long ago. He came up, he saw what the scientists had been doing over the last couple of 100 years, and then recognized that things changed in certain ways very quickly and then didn't, and everyone kind of didn't talk too much about how science moves around, and the changes in science didn't occur as quickly as other times. So he kind of put a theory around this idea called paradigm shift. And this kind of is the underpinning of what we're doing today. So that's why I'm introducing it. So for science to gain knowledge about the world around us, he said that we have a collective understanding about what that is. So scientists and normal people, through information that they gather from knowledgeable people, have this understanding about the world around them, what theories, what ideas, what concepts are the scientific knowledge of the day. But that should be backed up by evidence and reproducible experiments. If scientists then start to go, hold on, the information we have, or the theories we have, or the experiments we're doing, that doesn't ring true all the time. Oh, hold on, there's a problem. Oh, hold on, over here in medicine, hey, we're trying to apply this theory or this concept that people have said have worked, scientists have said worked in the past, but it actually doesn't work for this, this, and this part. Oh, physicists or astronomers or astrophysicists, they're trying to do these things and trying to apply the knowledge that have come before them, but it's just not working. If a lot of scientists start to say that, then we have a crisis. And that crisis is where a lot of scientists go, no, there's something really fundamentally wrong with the theories or with the equations that we're using. So something has to change, and significantly change. And that's what a scientific revolution, and especially that's what the scientific revolution was all about back in the 1600s, where there was a lot of people and a lot of they weren't called scientists at that point. That was around the 1800s that people started calling themselves and other people scientists. But back in the day, calling themselves, humanists, and Mrs. Taylor will talk about that, and philosophers, and just free thinkers of the day, were trying to do some experiments, and things just weren't falling into place. The information that they were trying to apply from from history and from other people in the last few hundred years before the 1600s just weren't really cutting the mustard. They weren't answering or explaining the observations that these people were getting at the time. So there was a revolution in science around the 1600s. And we've stayed the course fairly well up until then. So just quickly, I know Mrs. Taylor will probably do this in a little bit more detail. Who were those people? And kind of it hints at this Earth situation here and the sun. So if you know anything about science, you might know about this next one. So Ptolemy, here back in pre-1500s, the idea was where Earth was in relation to the solar system. We were the common trend. The theory was that we were at the center of the universe. And Ptolemy, and this is the Earth here, and then everything revolves around us. And the observations rang fairly true. If you looked up at the sky and you see the sun going past and the moon going past and the stars as well going kind of past you, you would, without any other knowledge, you'd go, well, we're sitting still because I can't feel the Earth moving, and everything moves around us. So that was a pretty fair observation without technologies like telescopes. But as you probably know, telescopes were invented and lenses were invented. So we have this man in the 1600s, Copernicus, and he used his knowledge and understanding at that point to formulate and hypothesize that we'll know the sun is at the center of the universe. And that's you might hear the words geocentric, which is Earth-centered. Ptolemy's one. We moved on to a heliocentric or sun-centered solar system or universe at that point in time. Now, Copernicus, interestingly enough, didn't get this idea just off the top of his head. This heliocentric model was already developed, not in the 1600s by Copernicus, but by this guy here. And you might recognize by, how old it is, and we don't have a pretty photo of him. This is called Erasmus of Samos. And back in 300 years before Christ, 300 BC, Erasmus of Samos actually developed and came up with the thought, not a theory, but thought, and had a few images and diagrams to suggest that also the sun and not the earth was the center of the universe. So even 300 BC, there was Greeks saying that was the case, and now we agree the sun is the center of our solar system anyway, and then we revolve around that sun. And the other ones, so that was a significant shift in understanding of that day, and I know Mrs. Taylor is going to go further into that. The other shifts and significant changes that changed a lot of people's ideas about how the world worked were these ones. So we have William Harvey, and that's got to do with how blood and the heart pumps your blood around your body, and instead of just having one pump, the heart is like a two-pump system, which you can see here. One pump on that side taking it around here, and one pump on this side taking it around to here, the pulmonary and the systemic system. So William Harvey developed that idea, which is a significant change in how medicine, how surgeons worked on the heart and on people's veins and arteries, because of William Harvey's new theory. And then we've got Darwin and his evolutionary theory here, and that was a significant change to the concept that was prior to that on how organisms have changed over time. And then we've got, really recently, we've got the computer chip. That was a significant change in how technology just leaped forward with the development of that computer chip. And then we've got Louis Pasteur, and this is Louis Pasteur, where he was, and if you, we would not have vaccinations and vaccines. We wouldn't know that microbes, bacteria, viruses were the cause of disease unless we have Louis Pasteur as well. So all of these people and the inventions or the concepts that they came up with had a significant and made a significant contribution to change people's ideas in a large way. All right. So in order to do that, they caused, as we went before with Thomas Kuhn, caused that crisis in science that many scientists, or, you know, if we go back to these guys, the thinkers of the day debated, discussed, and weren't agreeing anymore, and so there was a crisis. And so we can say in hindsight anyway that there was a revolution in science, and a scientific revolution. So let's go to today's work. Well, now we know the past, and science hasn't just slowly made more knowledge and more knowledge and more knowledge. It didn't work like that. There was kind of a lull in how much knowledge was developed, and then there's a big push forward in a short amount of time, and you'll go through the Enlightenment with Miss Taylor as well, and this is just a part of the Enlightenment. But that gives us a good foundation and a springboard for today's short little activity. It shouldn't take you, I don't want you to spend more than like 10 minutes on this next activity. So here it is. What are the challenges that are causing scientists to have crises or concerns or issues or questioning what they already know today? There's a few of the big ones. So firstly, we know a lot about the universe, but did you know that we don't know that anything about 85% of the matter or the energy that's in the universe we can't account for? We just don't know where it is. It should be there for the universe to work the way that it works. It should have a certain amount of energy, a certain amount of matter that's there, a certain amount of stars, asteroids, planets. There should be a certain amount of mass in the universe for everything to work the way we see that it's working, but it doesn't. So they've calculated that 85% we don't know where that mass is. It's just we don't know. So that's a big issue. Like if we didn't know, oh hey, look, when you're writing out an equation or something in maths and you go, oh, gee, I'm only off. It's meant to be 22, but it's 21.9. Oh, that's all right. That's pretty close. Well, that's all right, but think, hey, I'm adding up all the masses in the universe by what I can see, and I can only get to 15% of what it should be. Like, I should get to 100, but no, I can only get up to 15. Oh, where's the other 85? Oh, gee, I've missed something big, haven't I? That's a big problem. Same thing with now they've kind of come up with a really good theory about this, but the second one would be what actually is mass? What gives you weight or mass? Well, that never was, that was always a problem. Physicists didn't actually know where we get mass from, where the atoms actually get mass from, where your protons, neutrons, and electrons. How do those subatomic particles have mass? Well, there's a theory now going around about the Higgs boson particle, and you can research that if you want to. That interaction of the Higgs boson and the Higgs field will give you mass, but that's still a debatable theory at the moment. And the last one is, and quite a current one, is the issue and the crises of antibiotic resistance. We're given antibiotics if you're sick from a bacteria, but a lot of the time, some of the times now, not a lot, some of the times now, there's antibiotics that just don't work on certain bacteria, which is becoming a crisis in medicine. So, finishing off this activity today, what I'd like you to do is just spend 10 minutes. What are the issues? I want you to research. What are the areas that are challenging science? And that could be just what you put into your search engine. What are scientists questioning at the moment? What are the challenges for science or scientists at now? All right, so just put that into your Google search. See what comes up. Do some research. You can look up these ones that I've bolded before, like dark matter, Higgs boson, what gives everything mass, or antibiotic resistance. Don't spend much time on them. I'm not after you kind of being experts in this area. I just want you to look and be able to see that the questions of science are still out there. And all I need you to do is write one paragraph, 4 sentences and 4 sentences only, to explain why science hasn't been able to find the answer. What is it about the question? Why can't they find where the mass is? Why can't they? What is it about the Higgs boson that took them so long to find that it was actually the Higgs the Higgs particle that gave everything mass? Why are scientists scratching their heads going, well, what are we going to do about the antibiotic resistance? And again, you can't get this wrong, all right? There are no wrong answers here. Write what you think. Now, you could go even further and say, and this is, still an answer to here. You could go, well, what's the big things currently that are crises scientifically as well? Well, one of the big crises is climate change. What are we going to do with climate change? Big question. You don't have to answer that, but you need to answer why scientists just don't have an answer. Well, what do they need to find the answer? All right. And again, you can't get this wrong. Just think it through. What are the other big issues at the moment? One of the big issues is we want to get to Mars. Well, why can't we do that now? Why can't scientists just kind of push it, get us all on a nice cruise and tour to Mars? We can do it, with our last few months with our just up above, 80 kilometers to 100 kilometers. Why can't we get to Mars? Why is that so difficult? So today, you've watched this video. Hopefully you've learned about how science changes and how we can look back to predict what there might be and what problems or issues or interesting things are going to come for science in the future. All right. You don't have to write this paragraph on a due work, so that's not necessary. Just write it somewhere and and think it through. All right. Good luck. Go and do some research either on some of these 3 things or on one of your own and write that one paragraph. Good luck.